What is going on? Welcome to part 12 of our intermediate Python programming tutorial series. In this video, we're going to be using multiprocessing along with Beautiful Soup as an example of when multiprocessing could be advantageous. So if you don't have Beautiful Soup, one thing you can do is come to pythonprogramming.net. You can type in Beautiful Soup, enter, we'll go here. And come to this tutorial, and either you can just read this pip install Beautiful Soup 4, pip install LXML. Make sure you got those two things. If you need to know some of the basics of Beautiful Soup, you can go through. It's a pretty short series. There's only 4 tutorials, and really you could probably be fine. Just 1 and 2 would be good enough. Anyway, make sure you have Beautiful Soup and LXML. So, or a parser that you want to use in place of LXML if you want. So what we're going to do is we're going to run through a really quick, and not so quick, it'll take us a little bit, but I'm hoping to just do it all in one video, an example of using multiprocessing with Beautiful Soup 4. Let's do it. From multiprocessing, we're going to import pool. We're going to import BS4 as BS. We're going to import random. We're going to import requests, and we're going to import string. Random and string is so we can start with a random string. I'll show you that very quickly. Request, so we can actually make the request to get the source code. BS4 to read the source code, and multiprocessing pool to do the multiprocessing. So we're going to define a random starting URL. What this is going to do is return to us 3 random characters, and we're going to say those 3 random characters plus a .com, or really HTTP plus the 3 random characters plus a .com, basically, is going to be our starting URL, the URL 0, so to speak, where we're going to begin the parsing. So just a random 3-letter .com domain. We're assuming that they're going to have something there. A lot of them are probably parked, but we're going to go ahead. We'll have some handling just in case there isn't anything there. So let's go ahead and do that. So we're going to say starting equals, and then we're going to do empty quotes dot join random dot system random for a nice true random, or as good as it's going to get. Not true, but come on. Choice. And we're going to choose string dot ASCII lowercase underscore lowercase for underscore in range 3. Pretty long line. Pretty sure that's going to violate the 79 characters, but we don't care. We're not going to hold ourselves to that arbitrary thing. Moving along. That's our starting 3 characters. So basically, it's going to choose some random lowercase characters for the range of 3. So 3 random lowercase characters. Then we're going to say the URL itself is going to be this join, and we're going to join http:// the starting and .com, and we'll add our spaces there. We'll be Pepe there. Now, now we just return that URL. So that's just going to be some random URL. We can do URL equals random starting URL, print URL. There we go. Our starting URL, cdw.com. All right. So that's how we can get random URLs. Now, one thing that might happen as you post, basically what we're going to do, I suppose we should explain exactly what we're going to do. So we're going to create a spider here. And the main task of a spider might have multiple subtasks, but the main task of a spider is to go to a website, find all of the links on that website, and then go to all of those links, right? And just slowly spider web out into the entire interwebs. Okay, spider. Now, while you're on those websites, maybe you're going to do some stuff, but we're not going to code that part. We're just simply going to code getting a ton of URLs and actually like crawling around. So anyways, random starting URL, we got that. Now what we're going to say is define handle local links. So many times you're going to find that on a website they use local links. So you might have an href that is like this, and that's that's going to the contact page of your website, which is, you know, in our case with CDW, that was going to be CDW, that corresponds to cdw.com/contact, but the actual reference is just to this, right? And your browser just knows what that means. But when we go to make a request via requests to pull data, and we feed that as the URL, we're going to get an error. So we need to handle for those local links. So we're going to say if link.starts with a /, then we're going to just return join, and we're going to just join the original URL to the new link, else we return the link. Simple enough. Let me make some space. Now what we're going to do is we're going to define really the crux of this, and that's going to be get links. And we're going to get those links from some URL. And then we're going to have some tries, and we're going to have some exceptions. Except. We'll come to the accepts. Let's talk about the try first. So first, the response is just going to be requests.get whatever the URL is. Then we're going to say soup equals bs.beautifulsoup. The response.text value, and our parser's LXML. Then we're going to say body equals soup.body. That's just the body information, basically. So we're going to hopefully avoid nav bars, but we probably won't. A lot of times a nav is part of the body. Some websites even have multiple bodies. I'm not looking at my own source code, but PPNet might even have it, or pythonprogramming.net. It's PPNet in the cool kids. Anyway, links equals, and here is where we could have a really long line, and I'm just going to break it up so we don't, but we could. But we're going to have basically 3 links equals statements here. But anyways, link.get, and we're looking for the href. So link.get href for link in body.find all tags that are a tags. So that's all of our links. But of course, we need to do a couple of things. We need to handle local links and possibly encode them. But anyway, now what we're going to say is links equals handle. Let me just copy this. Handle local links URL link for link in links. Yes, good. I was blanking on where we were actually acquiring URL, but I'm like, okay, yeah, it's coming from there. Okay, now finally, I suppose just in case, we'll add in a quick encode. So we're going to encode string link.encode ASCII for link in links. Hopefully that's good enough. If so, we'll return the links. So what this is going to do is we're going to return a list of links that we find on any given URL, and we will handle for local links by appending or adding or joining the original starting link to the kind of local link. Great. Now what happens when things go wrong? So first, what might go wrong? One issue is maybe there are no links on the page. That's a problem. So if that happens, this will just be, basically we'll be searching for body.findAll, and that will be none. There will be nothing there. So it's going to be a none. So we're going to say accept a type error as E, and we're just going to print E, and then we'll just print a message to ourselves that's like, got a type error, probably got a none that we tried to iterate over. Good enough. If that happens, we just return an empty list. And that's acceptable to return an empty list for our program. Now we're going to say accept maybe index error as E. And we're just going to say print E. And again, here is basically we probably did not find any useful links returning empty list. Return empty list. Make some more space here. Some other errors that we might have is accept attribute error as E, print E. And then again, an attribute error might be if we don't, I'm trying to think here, because we got none that we, this would be if we try to iterate over none. This would be if we're attempting to iterate through the links, I would guess. And then here, attribute error. In this case, I'm pretty sure this would also be an error if we threw basically no links. Anyway, there's a lot of handling for if we don't get links, or we get bad links or strange links. But anyways, we'll just say likely got none for links, so we are throwing this. Okay, and if all of those fail, you probably, exception as E, have like a general exception. This will catch all other exceptions, and you probably should print stringy, or even just let this exception hit, like not have handling for that exception, because here we've got, okay, we understand that these might be errors that might happen. There's no list. We're trying to do something with none, and we can't do something with none. Here we're trying to assign an attribute, and we don't have that. So here you might not want to have this exception, but there still might be an exception, like maybe a connection error. So if we take a while in URL, or actually we're using request, but if we take a while with request to make the connection, we might actually throw an error there. So I'm going to leave this error here, but just know that in most cases you probably wouldn't want to. But in this case, we have like an outside environment that we can't predict. And we're making the active choice here that since we can't predict that outside environment, we've done our best to predict basically these things. If something else happens that we just didn't predict, we'll still print the string E. We're still going to return an empty list, which we forgot to do here. And then, you know, maybe do some log this error, right? Or something like that. Save it to a file or something that you can look at. Don't let this just totally pass without any sort of notification to you. Okay, good enough. Now let's do the main. So we're going to define main. We'll say how many. Basically, this will be how many links do we want to kind of start with. Let's just say we'll do 50. P will equal pool, and we'll just say processes equals how many. So we'll have 50 processes. Then what we're going to say is parse_us. This will be a list of links that we want to parse. That will be random starting URL for blank in range of how many, however many links we actually want to have. Now we're going to say data is equal to p.map get the links link for link in ParseUS. So what we're doing here is we're saying ParseUS, this is going to be a list of URLs, basically a list of 3-character URLs. And then we're coming down here from basically this will be the data that we basically the same as what we did in the previous tutorial where the return was like a list of 0, 2, 4, 6, 8 and so on. This time it's a mapping, and it's going to be lists of URLs that we get for all of the links in ParseUS. You might be able to guess already that what we're going to do is ParseUS, this starting value, is a list of URLs. What are we getting back from here with getLinks? A list of URLs. Thus, this could be a process that just recurs infinitely. But not yet, because data is a list of lists. So what we're going to say is now data is going to be equal to URL for URL list in data for URL in URL list. How's that for list comprehension? What is that doing? So for every URL in each of the mini URL lists, and then for each of the mini URL lists in all of the URLs that we have, which is data, we're saying what we want to do is now have a new list, which is just those contents. So this is a way of taking a list of lists and taking the data from each of those lists in the lists and putting it into a single list. Fantastic. Okay, so now we've got a single list. We're happy, p.close. And then what might you do at this point? Well, data would in theory now become your new ParseUS. So maybe you would do a while true here. Maybe you would tab this over. Maybe you would say ParseUS equals data. Of course, we've got a slight multiplication in data there, but it's okay. And the process goes forever, but we're not going to do that. We're just going to run it one time. But that's how you would do this forever. And then we're going to say with open, and let's just say urls.text with the intention to write as f.write the string data. And finally, if name equals main, we run main. Great. Now, again, as we have learned in the past, if we run this via idle, we just won't see any output. So including in the output that we would not see is all of these errors. So let's go ahead and see just how many errors we do run across. So we'll open the command window and let's run this. Again, I'm going to type the full path to Python because I have multiple versions of Python. You probably just need to type Python. Let's do it. Oh, invalid syntax. Oh, don't give me this. What did we forget here? That looks legitimate to me. Link for link in ParseUS. Why is that an invalid syntax? It is in line 49. Data equals pmap. Really though, why is that a syntax error? Show me. Show me. Link for link. Enter. I wonder why it thinks that's the syntax error. But anyway, we are missing a comma. Great. Let's try again. Request is not defined. It should be requests with an S. Requests. I wonder if this is still... No. Okay, we'll try again. There we go. Malwarebytes is getting angry at me. Okay, we've got some errors here, but nothing that we... so none type has no attribute start with. Good thing we got none for the links. So probably starts with was the URL that we thought or something. We just didn't have starts with there. Here's another one that we just haven't handled. Yeah, max retries exceeded with the URL caused by new connection error from the request.packages. So yeah, we got some strange error there. So you could add these new errors that haven't been seen. We can see that and we're like, okay, yeah, that's understandable. Like we don't care about that error, so we can let that error go away, or pass. So in some cases, you want to basically only have exceptions for things that you have purposely built the exception for. So, silently passing exceptions is one of those things. I'm pretty sure it's in the Zen of Python. You at least definitely don't want to say this, like pass, right? That's not Zen of Python. But probably like if you're running and silently passing does include, even if you're saying print string E in your code, but you're running it via a cron job, you're never seeing that. So if you're not going to see the print statements, make sure you do log the error. Regardless, let's open urls.text, and sure enough, what we have in here is a ton of URLs. And a lot of these URLs are 3-letter URLs. Hoping to find one that is not a 3-letter URL. Yeah, oh well. One of them sent me to Malwarebytes thanks to Malwarebytes, so one of those URLs was not a good one. And I did see Malwarebytes got a little angry with me a moment ago. Unless I'm missing it, all of these are the 3-letter URLs. I kind of want to run it again just to prove that eventually you will get off of your original 3-letter URLs. Yeah, so then you also have like these links here. Let's run it again and let's see if we can get, just curious, and maybe we could, if this doesn't work this time, I'll pause it. Man, it's getting angry at me again. I wonder which website is not the website we want to go visit with. Malwarebytes is not like that. Yeah, to follow this tutorial at your own risk, because we're just visiting random websites. At least it's bigger URLs.txt. Well, this one's bigger. This one's at least. Oh no, it's KWH. Get me. Okay, here. Haha. We made it to Twitter. Let's zoom in. Where are you, Twitter? There we go. Twitter. We got Twitter. We got some LinkedIn here. We got YouTube. Oh man, it's game over. This spider has discovered the internet. Yes. p.com. It's a good 3-letter domain. DRD. I'm sure there's some more in here, but anyway, our spider made it onto YouTube, so we're good. There's some more Malwarebytes. I'm really curious what website that is, but anyway. There we go. We got to networksolutions.com, so a lesser known place. Air.com. Whew. That's got to be a valuable domain name. All right. Anyway, there you go. A quick, simple example of applying multiprocessing to Beautiful Soup, because parsing takes a lot of time, but in that case we just parsed 50 websites in a relatively short order, and got the links to all the stuff that we needed. And actually at one point in time, it's not that we didn't just pull links. I mean, at one point we had their entire website, so you could do all kinds of stuff. There are certain legal issues when it comes to storing people's content, especially if you go about sharing that content on your own website and so on. So wouldn't necessarily suggest that you crawl people's websites and repost stuff. But anyway, that was, 50 websites. We downloaded all of their information. Like, we have all of their information here. So that's actually a pretty large task to be doing. And then, of course, we're pulling apart that information, grabbing just the links, throwing away the rest of the stuff. So that's actually a fairly tedious process. Not really sure how long it would take to do 50 websites in line with each other, rather than processing this in parallel. But probably not that fast, especially since a lot of the time you might just be waiting for a connection to time out, right? So just one of those connections timing out probably would have taken that entire time. Anyway, that's all for this tutorial. If you have questions, comments, if you have improvements, I really just ran through this really fast. So there's probably some improvements that we could make, but I tried to include some things like join and stuff like that. And of course, list comprehension. So hopefully that was not too tedious for anybody. Anyway, questions, comments, leave them below. Improvements, let us know. In the next tutorial, we're going to be jumping into object-oriented programming, so stay tuned for that. I will see you in the next tutorial.